Hello, this is Josh Bartleson, and this is my project on two-dimensional vectors. So, to begin, what is a vector? A vector is a quantity with both direction, positive and or negative, as well as its magnitude, which is its size. So, as you can see, this vector has direction, east, and it also has a magnitude. So the magnitude is its length. So a longer vector has more magnitude, and vice versa. So, as far as direction goes, the left and downward positions are negative, and the up and right positions are positive. So, as we can see with negative a, it's moving down and to the left, so that would be a negative vector, and up and to the right for vector a, positive a, so it is positive. So now what do we use vectors for in physics? Vectors typically are going to be used in diagrams. This one, for example, is a force diagram. As you can see here, we have the normal force being displayed by a vector, the applied force, the gravitational force, and the frictional force all on this object being displayed by vectors. This cleans it up, gives you uniform, it makes it clean. So not only does it display things like force, we also display velocity, power, work, momentum, and other quantities using vectors. So these are very, very important. These are the stepping stones of physics, one of the first things that you'll learn. So now vectors have different parts. As you can see here, they have tails and heads. So the tail is the beginning of the vector, it's where it begins, and then where it ends up is the head, which is represented by an arrow. And as we stated before, it has both magnitude and direction. So now they also have x and y components. So the x component is how it moves horizontally. As we see here, it's represented by this red arrow down at the bottom. That would be its horizontal component, or the x component. Now the y component, represented here by the green vertical arrow, is how it moves vertically. So the change in the vertical from the beginning to the end. So now how do you go about drawing vectors? So the first thing you want to do is to read the problem or determine the scenario, which will allow you to determine the direction and the magnitude of the vector. For convenience, we'll be using a vector with a magnitude of 316 newtons and a direction of 35 degrees north of east. So the first step is to determine a reasonable length for your vector. And what I mean by that is if you had a vector of 5 newtons and one of 10 newtons, you want the vector of 5 newtons to be shorter than the vector with 10 newtons, simply because that just logically makes sense. Next, what you're going to want to do is logically locate where it should be on the graph. And what I mean by that is if, for example, with our vector, it is north of east. So if east runs here on the x-axis, then we need to go north of east. So if we go 35 degrees north of east, we end up right around here. Then all you have to do is locate, find that reasonable length for that vector, and just go from tail to head, draw your arrow in, and make sure you label the magnitude and direction for your convenience and for problem solving. Now, 2D vector addition. This is the next step. This is once you've learned how to draw vectors, this is the next step. And I know these are the questions that's on everybody's mind, which would be why do we add vectors and how do we add vectors? So we add vectors simply to find the resultant between the two. These typically will be things, because in real life, we don't just move in one direction. We don't just walk in straight lines. We walk in diagonal lines. And this, using resultant, we can find that displacement, how far we've gone, by calculating both, by factoring both into the equation. And then how do we do this? Well, in my next PowerPoint, I'll be showing you how to do that.